Hey guys, so we left off in part one of this video with this slide saying that sometimes finding the slope can be as simple as counting. We can pick our 2 points here and we can see that from this point down to this point, if we draw a line from that point, oh, I shouldn't have chosen red, from that point to this point where they meet here, you can see that we went down 2, so our rise was a -2. And our run, we moved from left to right, so we moved a positive 6 spaces. So we can write that as -2/6 or -1/3. Again, if we're using our Mr. Slope face, we can see the line is a downward sloping line, and that was a negative slope. And when we found the slope, we found that indeed we did have a negative slope here, -1/3. When finding slope, the sign of the slope indicates whether the line slants up or down, moving from left to right. So I've said that multiple times. You should be really familiar with this guy right now. From left to right, it goes up, goes upward, and so that is a positive slope. If from left to right, it goes downward, it's a negative slope. If from left to right, it's just a horizontal line, it's a 0 slope. And if it's a vertical line, it is an undefined slope. The absolute value of the slope indicates the steepness of the line. So let's take a look. We've got positive slope, negative slope, a slope equals 0, horizontal, and slope is undefined. That's going to be a vertical line. If we had just let's go back here to a blank graph here. Let's say that we had a slope of 1/2. That means for each time that we go up 1, we'll go over 2. Up 1/2. You can tell that's a pretty gradual slope if I connect those points. We just said the absolute value determines the steepness. Let's say that my slope wasn't 1/2, but instead was just 2, or 2/1. Let's check out the steepness of this graph. The absolute value of 2 is greater than the absolute value of 1/2. So let's do a slope of 2, which would be up 2/1, up 2/1, up 2/1. So you can see the steepness of this, still a positive slope, but much steeper. The greater the value of our slope, the steeper the line is going to be. There are many different notations for slope. We've already looked at m, and that was equal to rise over run, which we could also write as y2 minus y1, or x2 over x2 minus x1. We can also write it as delta y over delta x. This triangle shape is the Greek letter delta, and delta just means the change. So the change in y over the change in x. How much did y change from this point to this point over how much it changed from one x value to another? Those are all different ways that you may see slope notated. All right, guys, today we found the slope of a graphed line, and we also found the slope of a line that wasn't being graphed passing through 2 given points. And we really worked on making sure you understood this formula for finding the slope. y2 minus y1 over x2 minus x1, and slope is notated with an m. When you see that m and we're talking about linear equations, we are talking about the slope. If you guys have any questions, be sure to write those down in your notes and ask me next class.